Hello students, welcome to class 11 physics class. Last day I will send this PDF, only the notes, no video is there, that's why today I upload this video. I make this video. Today we discuss second law of thermodynamics. In this year in your syllabus the details about second law of thermodynamics, that means the application, is not there. Okay, just the second law of thermodynamics were the statements only included in your syllabus. All about rest all about the first law of thermodynamics that we studied in a last video or in last classes. So let's start with the second law of thermodynamics. Second law of thermodynamics consists with a two statement because two scientists discovered this law, but the main thing, the main uh, content is same. The way to define the statements is different. So first one is a Kelvin Planck statement and second one is a Clausius statement. So in your exam, if the question is there, state second law of thermodynamics, so you write both the statement. If it is mentioned that you write the second law of thermodynamics, Kelvin Planck statement or the Clausius statement, then it is uh, then only you can write that statement. If nothing is mentioned and it is in the question paper it is written that state second law of thermodynamics, so you have to write two statements. So Kelvin Planck statement, this law is applicable for heat engine. This heat engine is not there not included in your syllabus, but heat engine consists main parts of the uh, heat engine, that is three parts. First one is a source which has a infinite thermal capacity. So if small amount of heat is absorbed from um that source, so there will be no change in the temperature. That's why it is considered the source which has a infinite thermal capacity. So we can consider it is T1, temperature is T1. Second part is the working substance or the machine or the motor or that engine which perform the work done, from where we get the output. And third part is the sink. Sink means when we discuss the second law in details, we see that the whatever we absorb from the source, from input, the total input or the heat absorbed from the source, the total heat does not convert it into the or does not go to the sink. Few amount of uh, converted into work done as the output, and the rest of the go to the sink. Okay, so the third part is sink which has a infinite thermal capacity, but its temperature is it is a cold reservoir. The source is a hot reservoir and the sink is a cold reservoir which has a thermal heat capacity. Temperature is T2. So if any amount of heat, small amount of heat which is rejected by the engine, if it will go to the sink, then there will be no change in the temperature. That's why we consider the sink, that is a cold reservoir which has an infinite thermal capacity, source which has a which is hot reservoir, heat capacity T1, and the third part is that another one part is the engine or the working substance. This is the construction of heat engine. So let's study the statement. Kelvin Planck statement. It is impossible for heat engine to produce a network in a complete cycle if it exchanges heat only with bodies at a single fixed temperature. It is not possible. It is not possible that in a complete cycle that it will absorb the heat from the source and directly go on other than that temperature go to the sink. It is not, it not in a possible in a fixed temperature. Some amount of heat is used for output, work done is there. So suppose q1 amount of heat is absorbed from the source, so the few amount of work done converted to work done, and the rest, that is if we consider q2 amount of heat is absorbed by the sink or go to the sink. So we can say that Q1 plus W, W plus Q2, that is equals to Q1. W plus Q2, that is equals to Q1. So W equals to Q1 minus Q2. W equals to Q1 minus Q2. Next is a Clausius statement. This statement is applicable for refrigerator. Just refrigerator is opposite to the heat engine. Heat engine, the heat is absorbed from the source, but the refrigerator, what we also see in our household, in our house, the fridge is there. So what happened inside the fridge? That is a cold. So that means the heat is absorbed from the sink and it is go outside the go to the source. You see that in the backward side of the fridge it is very hot. So just it is the opposite direction. It will happen in the opposite direction or opposite manner compared to the heat engine. So Clausius statement, it is impossible to construct a device operating in a cycle that can transfer heat from a colder body to warmer body without consuming any work. Without any work it is not possible. Some amount of work also be there. That is also applicable for Kelvin Planck statement, that is also applicable for Clausius. Both main content is same, that it is not possible to construct an engine which is only absorb a temperature from any either source from the sink and go to the transfer that heat in a whole cycle to the sink or the source. Some amount of work done is there. In heat engine, it is absorbed from source, then work done, then rest of the amount is transferred to the sink. In case of a Clausius statement, refrigerator, the heat is absorbed from the sink, some work done, the rest amount is go to the source. Clear? This is the second law of thermodynamics. This is a construction of heat engine. Source at T1, Q1 amount of temperature is absorbed, then some work done, then Q2 amount of it go to the sink at T2. So W equals to Q1 minus Q2. Next is a reversible and irreversible process that already we discussed in a first video. So in this PDF and we discuss. So reversible process, it is an ideal process, but this is not in the present or in a reality it is not possible. In a reality it is not possible, which is never occurs. That's why it is written over there, which never occurs. While the irreversible process, it is a natural process, and this is commonly found in the nature. This is commonly found in the nature. For example, it is written, when we tear a page from our notebook, we cannot change this and untear. This is an irreversible process. Whereas when water evaporates, it can also be condensed in the form of rains. This is a reversible process. Okay, this is a examples of reversible and irreversible process. So reversible process, it is a thermodynamic process. A thermodynamic process is reversible if the process can return back in such that both the system and the surrounding return to their original state, original configuration, or the initial state, with no other change anywhere else in the universe. It means both the system and the surroundings are returned to their initial state at the end of the reverse process. Whatever the changes occur, after some time it will again return back to its initial position or initial configuration without any change. That is called reversible process. That means if you started from 1 to 2, then 2 to 3, 3 to 4, then again it return back to its initial position 4 to 1. This is a reversible process. In this figure, this is explained here, this graph is explained here. The system undergoes a change of state 1 to state 2. The reversible process can reverse completely and there is no trace left to show that the system had undergone thermodynamic change. During the reversible process, all changes in state that occur in the system are the thermodynamic equilibrium with each other. Now, this reversible process is two types. We can divide in two parts: internally reversible process, another one is the externally reversible process. Internally means the process is internal reversible process is no reverse in irreversibility occur within the boundaries of the system. In this process, a system undergoes through a series of equilibrium state, and when the process reverses, the system passes through exactly the same equilibrium state while returned to its initial state. That means, suppose you start walking from your home to market, then school, then reverse school to market, then your home. So same path, just in a reverse process. This is an internally reversible process. Exactly same path you followed. You have made two or more choice. You can also, from school you go to the big bazaar, then from anywhere you can go to the go and reach your home, but you follow the same path from your from at the first from your home to, suppose, in market, any particular shop, any particular shop you cross. After that, uh, or the anything, many shop are there. Then the school, from school, that shop, and then your home. This is the internally reversible process. Externally, in externally reversible process, no reversibilities occur outside the system boundary during the process. Heat transfer between the reservoir and the system is an externally reversible process if the surface of the contact between the system and the reservoir at the same temperature. That is a heat engine. The heat is exchanged between the two reservoirs with some work done, with some output. Whatever the work done, the working substance that we get as the output. In case of a refrigerator, you see that the outside and backside of the refrigerator is too hot. That is a work done, rejected heat. This is the externally reversible process. So process can be reversible. There is a conditions. You see that the diagram, initial process and the restoring process. First, dissipative force must be absent, and the pressure process should be occurred in infinite small time. These are the two conditions to satisfy a process can be reversible. Clear? Okay. So in simple words, the process which can be reversed back completely is a reversible process. This means final properties of the system can perfectly reverse back to its original properties. The process can be perfectly reversible only if the changes in the process are infinitesimally small. The practical situation, it is not possible. It is not possible. You cannot get this reversible process. There, whatever at starting, whatever the um, properties is there, when you get almost equal but not equal, little bit difference is present. It is not possible in practical situation. So hence the reversible process is also an ideal process. The changes that occur during the reversible process are in equilibrium with each other. Okay, this is all about the reversible process. Irreversible process means it does not return back to its initial position or initial configuration or the state. So irreversible processes are a result of straying away from the curve, therefore decreasing the amount of overall work done. An irreversible process is a thermodynamic process that differs from equilibrium. In terms of pressure and volume, it occurs when pressure or volume of a system changes dramatically and instantaneously, that the volume do not or the pressure do not have the time to reach the equilibrium. This process is very fast. They will not get the time to reach the equilibrium. That's why they will not return back to its initial state. This is a reversible process. You see that this is a reversible process. This is a classic example of a reversible process. is allowing a certain volume of gas release into a vacuum by releasing pressure on a sample and allowing it to occupy a large space. The system and surrounding are not in equilibrium during the expansion process. This is the all about the irreversible process. So this chapter is completed here because and one thing, that second law of thermodynamics is discovered by scientist Carnot. So that heat engine, that is it is called Carnot heat engine, and the working of Carnot heat engine and its expression for work done, efficiency, how much it's efficient, it is not included in your syllabus this year. I don't know what happened in the next year. Next year you are in class 12, so no headache. uh, this chapter up to this reversible process, irreversible process, no heat engine, refrigerator, their work done, efficiency is not there. That derivation is not included in your syllabus. So this chapter is very easy. That derivations are mainly very important and the numericals. So you practiced it in your copy 2 to 3 times, then it is habituated to you. It is a very easy chapter. Clear? Okay, so if you have any problem, please inform me or write in a comment box. Thank you very much. Stay safe, stay healthy, be happy always. Tata, bye bye. Have a nice day.